Good afternoon. This is our Development and Growth 2. Last time we were looking at innovation models and we studied a very simple one. Today we're going to look at more different stuff. We're going to look at various models in their simplified form to learn more about technological progress. Let me start my whiteboard and show you some interesting stuff. Okay. All right. So first, I would like to refresh your minds about the sources of productivity growth. Okay, so remember that I told you there are three channels. One is sectoral reallocation of resources, right, from low productivity to high productivity sectors. So that, of course, creates a productivity gain, as I showed you last time. One other thing is innovation, right? And if you remember, I told you that there are two dimensions of innovation. On the horizontal axis, we have firms or the intermediate products or consumer products, however you define. So they have this productivity distribution. So in time, there's horizontal innovation and there's vertical innovation, right? So existing firms become more productive and there are new firms entering the economy. So technological progress through innovation is realized along this dimension, right? So you may imagine that there is this landscape of technology and there's growth. Finally, we're going to look at technology adoption models. Okay. Sometimes we call these models imitation, right? So innovation versus imitation. Okay. Now today, so we discussed that already, and we are here right now, and I showed you a very simple model. Let me summarize it over here. That was a very simple model. So there are two types of labor in the economy, right? So one type is for innovation, and the other type is allocated to production. Okay, and the knowledge in the economy basically grows as a result of this labor allocation, and production level depends on, of course, this, right? So once you know what fraction of labor is allocated to innovation, then you know the growth path of the economy. Once you know the growth path, you define YT in this way, right? So you then understand the growth rate of output per worker. Now today I'm gonna continue discussing innovation models. Okay, I'm gonna show you a couple of different conceptual frameworks that might be interesting, and then if we have time, we're gonna look at technology adoption models. And then I will show you there a couple of different models as well that underlines different mechanisms that we observe in the real life. And surely there are other models that kind of combine these two mechanisms. Okay, actually, you can also write, I'm sure, a model that combines all these mechanisms as well. But most of the time, we have, you know, in the research side of this game, usually we start with a question, of course, and the model we use depends on our research question. Okay, so we designed a model to fit our research questions, to serve our purposes in a particular way. So usually we don't do this in growth theory. So you know, some people may imagine doing this, but what we usually do is to start with simple models and try to find a sufficiently complex model that would be interesting, but still solvable, a simple model, because we want to analyze it, right? So we don't usually start with the notion that, okay, I will write the most realistic model. So this is not very useful in practice, because if you really develop a very realistic model, possibly it will not be very simple to solve, so it will not be very useful for economic analysis. Okay, so let's look at slightly more complicated models of innovation. Okay, and here what I will show you is this. So suppose that there is a sector. So suppose that in this economy, there are three sectors. Okay, so this is a slightly more complex version of the model we saw already, and still a very simple version of this paper by Paul Romer. This paper published in Journal of Political Economy in 1990. Okay. Now, the idea is this. There are three sectors in the economy. One sector is the final goods sector. The other sector is the intermediate goods sector. And the third sector is the research sector. Okay. Now, in the final goods sector, there is this final good produced by many different firms that are identical. Okay. Here in the intermediate goods sector, we denote these goods by XIT, right? So each I is a particular machine. And in the research sector, we develop new intermediate goods. Okay. So if you write the production functions, here we have something like this. There's, let's say, labor. Okay. You may use this. And there is a number of intermediate inputs. Let's say MT of them, right? And each of them enters the production function in this manner. All right. So this is the production function of the final goods sector firms, and we assume that this sector is perfectly competitive. Okay, so the firms in this sector, they take prices as given, so they maximize their profits. There's no excess profit in equilibrium, so on and so forth. Right? There's free entry, large number of firms, you know, all the typical stuff, you know. So in the intermediate goods sector, so here, as you see, MT is the number of intermediate goods, right? MT is the number of intermediate goods, and XIT is the units of intermediate good I actually employed, right? So there are many goods. For instance, I from 1 to 5, right? This means MT is equal to 5 at a particular time. So there are 5 different machines. Each machine is used by a specific amount, right? So for instance, X1T is equal to 2, X2T is equal to 1, X3T is equal to 4, X4T is equal to 1, and X5T is equal to 7. I'm totally making up these numbers right now. So these are the units of these machines that are actually employed by the firm. So for each of them, there's of course a price paid to the producer of these intermediate goods, right? So producers of these intermediate goods are in the intermediate goods sector, obviously. So this sector, however, is monopolistic. Okay, we are assuming that. So let me draw the boundaries here. Now we are assuming that this sector is monopolistic. So each I is produced by a monopoly firm. So how can we understand monopolistic market structure here? Well, perhaps there are some patent law, right? So there is a law or regulation that says, okay, if you are the inventor, if you are the inventor of this particular machine, then you have the rights to be the only producer of that machine for like 10 years or 19 years, right? So there are restrictions like this. So here you may assume something like that. Or in reality, of course, even if we do not observe such strict one firm setup as in the pure monopoly, we sometimes see oligopolistic models, or sometimes monopolistic competition features. So in the short run, it is more like a monopoly, but in the long run, there's entry, so it is more like competition. So there's of course so the model does not exactly correspond to what will happen in the real world, but it is not a totally crazy assumption to assume that there are some there is some market power that incentivizes innovation, right? So we know by heart that according to the all these Schumpeterian models, we know that technological progress must be incentivized through profit motives. So here we are creating that profit motive by making such monopolistic market structure assumptions. Okay, so what is the production function? The production function is one-to-one. Okay, so basically, if you are an intermediate producer, you take 1 unit of final good and convert it to machine I. So okay, so this is one-to-one. So how do we understand that? Well, very simple actually. Remember the Solow model. In the Solow model, how do you create a machine? Well, you create through investment, right? Where does this investment come from? Well, it comes from output, right? So there is a one-to-one relationship between output and capital, right? Same is true here. So there is a one-to-one relationship from final goods sector to the to the intermediate goods production. Okay, so that part is the same. So this particular one-to-one production technology, of course, implies that if the price of this is equal to P, then the marginal cost of producing each machine is equal to also P, right? So there's one-to-one correspondence. Now, finally, we have the research sector, and research sector is assumed to be competitive as well. Now, is this a very good assumption? Well, again, we can argue this may not be fully realistic, but in essence, research is free, right? So you can, so nobody stops you if you want to open a research firm or a startup, right? As long as you find as long as you have the funds, either through your own resources or through credit, you can open a research firm and try to develop or try to invent new intermediate goods. Why would you do that? Because the profit opportunities in the intermediate goods sector in the future will give you enough incentive for you to develop technology. Look at the situation in the vaccine business, for instance, right? So these vaccine, these pharmacological sector and all these companies, they have now the vaccine technology for COVID-19, but it is not public knowledge right now, right? Because there is competition among them. So that type of competition is important. I'm not saying research is completely a perfectly competitive business. Now, I'm not saying that, because there are in certain sectors and in certain countries, there are entry barriers, there are large fixed and sunk costs. In some technologies, there is the public good nature of that technology because of basic knowledge. So most of the time, governments make some initial investment to open laboratories, to educate the engineers and scientists and so on and so forth. Then the private sector benefits from that type of public externality to enter the research sector at the later stages of a research. So there's usually a transition from basic research to applied research, because basic research does not have any commercial side, right? I mean, imagine Newton, right? So Newtonian mechanics is very important for us to understand our nature, but just knowing Newtonian mechanics, just that pure knowledge or basic knowledge does not give you profits. But then, of course, on the applied side, you use Newtonian mechanics to do something useful. For instance, you create certain simple machines, or you create technologies for technologies such as steam engine or spinning jenny, things like that, all kind of related with Newtonian mechanics, obviously. Then you make profits, okay? So private sector, independent private agents are interested in these profit opportunities. So they are not like saints or angels, right? So they want something in return for their efforts and contributions. So in short, real life is not smooth and unproblematic as in the model case, but this is a good starting point to say, okay, if you want to do research, if you want to open a startup, then you are free to do so as long as you have the funds, okay? And then once they do that, they face the problem. The problem has two sides. One, there is a return, okay? That return is typically the profit, right? Profit when they go to this stage, okay? After developing the product, they become producers, and there's a cost. And cost is, you know, funds, humans, etc. Right? So they need money, they need people, they need laboratory equipment, and all of these stuff, right? So out of this, they must have a net payoff, as in profit, right? And in equilibrium, since this sector is perfectly competitive, this net payoff in equilibrium, of course, will be zero. Okay? So out of this, we will have an understanding of technological progress. Okay, so we will have growth rates, but let me pause here and I will continue after the break. But now, if you have questions before I show you the results of such a model, if you have questions about the fundamentals, I can answer them right now. Okay, no questions, great. So let's now take the break. It is about 1:38 right now. Let's meet at 1:55, okay? At 1:55, we're gonna continue with the equilibrium of this model. All right? I'm now ending the session and see you at 1:55.